Hello, my name is Layna Mangiapanello. I'm a sophomore here at Missouri State. I'm a double major in mathematics and secondary math education. I am quite involved on campus. I was a SOAR leader. I am in mock trial. I'm in Student Government Association as well as Hall Council. But I'm also in Kappa Mu Epsilon, which is essentially math club, which relates a little closer to my major. I played classical violin for a good 10 years before I came to college, and I still play in the orchestra.
Cool.
So last semester, I did an independent study project with Dr. Patrick Sullivan in the math department. It was paired with the course Math 343, which is statistics for educators. I met with him quite a bit, and we created our little project. So by the end of it, I kind of did a lot of little things. I had made some spreadsheets to find correlation between the free and reduced lunch rates of public schools and their proficiency in various math, English, science, history testing, and also how that varied for elementary, middle, secondary level schools across the entire Springfield Public School district. And I know we use that data in quite a bit. And then I also watched a recording of some of his other lectures for other classes for how to effectively teach students and kind of what the best method is there and how you actually get people to not just hear about math, but to actually understand it. It was really interesting. I have always been very passionate about mathematics education. I really like math, which is very controversial. And so it was really good for me to be able to see kind of like the perspective and some of those factors of like, it's not the student per se. There's so many things that happen, and also how teachers, you see a good portion of teachers who wanted to teach high school math, couldn't get past Calc 2, moved down to middle school, or moved from middle school to elementary. And so much of it is the barrier in mathematics. That's the part that they want to avoid, which I get it, I do. Not everyone likes math, that's fine. But there is a huge gap in how we treat math compared to other subjects. You'll hear elementary teachers sometimes, and this isn't their fault, but you'll hear things like, okay guys, it's math time. We only have to do it for 20 minutes. I know, it's math. Oh no, but it's only 20 minutes and then we can do reading. So starting early, and then I forgot those earlier. But part of my research was also looking into surveys that he conducted with Math 101 students here at the university on math trauma, and specifically like if they have it, and like what class, when did you kind of stop liking math? And we found out quite a bit about self-efficacy from that, and like your belief in your ability to do mathematics, and some of the correlations there in age and gender and whatnot. So it was really interesting to see kind of where the almost cutoff point of like, I don't like math because in third grade the teacher made fun of me because I couldn't count coins properly, and that's where they checked out. That's where they said, I'm done with math. No fault to anyone per se, but if you check out in third grade at fractions, come high school, college, you still don't understand fractions. And so how do you teach that so that they're not just plugging in something, but they actually understand where a concept comes from? And considering that I want to teach either high school or college, either way, I think it's really good for teachers to understand not just like the material that they have to teach, but what it means and why students would get it wrong. Because ultimately, it matters less that it's wrong, it matters more of what were they thinking, because they're not just putting down nonsense. There was a thought process. And so where is it wrong, and how do you correct just that part to get them to get it, instead of just you use the formula wrong, use the formula right, and then it's correct. I really think that there is links there. I have always identified as some form of neurodivergent. What that is, we don't know. But with that being said, mine has almost done the opposite. I'm really, really good at math. But I understand that that's what I have with math is not the default. It is not the standard. And I know there are people who it is not that they're not smart enough. And math is really nice and really great in my opinion, because there's a right answer. There's so many ways to solve one problem to get the same answer. Whereas if you go to a history class, it's like, okay, this event happened. Why? And then there's so many factors that you can't pin down an answer. In math, you get that one answer. And so because of that, I really and truly do believe that anyone can learn math. With that being said, if, say, you're making fun of students because they didn't get it on the first try, or you're not offering alternate ways to solve a problem, or you're not explaining why you're doing something, you're saying, just do it because I said so, that's not going to help them. Yes. And so there's definitely a lot of barriers in terms of students who are neurodivergent and how they learn math and some of the math trauma that they have associated with. And I really hope that by the time I'm teaching, I have some way to overcome at least some of that, so that it is very aware of, like, I know that you're coming into this not liking math. I don't need you to like math, but I do want you to understand it. And how do we get over that initial, like, I can't do it because it's math? Because really and truly, math has a right answer. Anyone can do math. It's just, how do you get them there? Yeah. There is so much to be said about how math from high school and your prior education will transfer to college, and what you do with that information. In terms of like having access to mathematics, I was very, very lucky in the fact that I went to a really big high school, and so I got to take like AP Calculus and AP Stats. I came in my very first semester, I was doing multivariable calculus. Most students are not going to have that, which is okay. You don't need to have that. But with that being said, there are so many students that simply don't have those opportunities, or they don't have really good teachers. And so if you've got a math teacher who doesn't like math themselves, doesn't have a degree in mathematics, there are math teachers out there who really and truly don't understand mathematics fundamentally. And so if you're trying to teach it and you don't understand it, it's no wonder that students don't quite get it. And then you start hitting other problems very early on. Doing my research with Dr. Sullivan, he gave me a statistic I'm probably going to misquote. There was a university, and I cannot remember which one, but they found that in the last decade, of all the students who came in with an ACT score, the math subsection of less than, or roll it back, it was from some large university that I cannot remember the name of. And they found that any student who started in their equivalent of Math 101, so like college algebra, if they were an engineering major, in the last 10 years, there had not been a single engineering major who graduated who started in 101. At some point, they dropped or changed their major. There had not been any.
That's why I'm not a physicist now and everything. I dropped out for my first year.
Yes, and then working over SOAR, I actually had a little bit of information that even he in charge of the Math 101 program didn't know. I was specifically a SOAR leader for Group 17. So we take care of the math, physics, computer computer science and engineering students. Great, lovely bunch. And there are a lot of really great kids going into calculus right off the bat. People are sometimes surprised to find that there are also students in that group who need to be in Math 101. And that's fine. You can still get that degree if you're starting in 101. A lot of people don't, through some failure of the system somewhere along the way. And he was telling me that in his data, because he teaches the class, he has access to the ACT scores. Anyone whose ACT score was below, I believe, a 15, no one with a 15 or below had gotten an A in Math 101. There just were no A's from that ACT subscore because they just didn't have the mathematical background to even get through 101. But one of the reasons I bring this up is over the summer, we ran out of Math 101 spots, and then we ran out of Math 103 spots. And it cannot possibly be the SOAR leader's job to look at a student and be like, hey, your ACT is too low. We're bumping you up a class. Go to the Bear Claw and do all your studying there and talk to your professor. So the professors don't know. The math department head kind of knows, but not really. The students don't even know that they don't qualify for the class they're putting them in. It was just kind of SOAR, but it was an evil we couldn't avoid in the sense that you can't just not put a physics student in a math class. They need a math class, and there are no more 101s. So you're starting in pre-calc, and good luck. So I was telling him about that and how this summer, we had to do that. And I know in summers prior, they even ran out of pre-calc classes, and so they were registering kids through OTC for their introductory math. So I was telling him that, and he's like, I had no idea that happened. What do you mean? And I'm like, there are students whose ACT scores do not at all qualify them for pre-calculus who are currently in pre-calculus because that's the only thing that we could register them for. And so you look at those gaps where no one really knows what's happening, and then you go back to I had a really mediocre math teacher in my rural small town math class, and it was COVID during my freshman year or whatever year it was. And it's so easy to understand why there's such a wide gap in what people know in terms of mathematics in those very beginning introductory courses. And so it really is patience and understanding, I think, for a lot of those professors. And I know from having friends who have taken some of the lower level math classes, they've been frustrated with the amount of homework, or how sometimes it feels like they're spending so much time on a fundamental concept, and the teacher is like, this is really hard, and it's, factorials or whatever it is. And they're like, I've already been taught this. I understand this concept. And then the teacher will be like, okay, now that we understand this concept, we're going to apply it. And then they spend a day and breeze through the application of it. And then they test them on the application of it, because if you understand the fundamental concept, the application isn't that difficult. But if you don't walk the students through how to properly apply, the students aren't getting it at that point. From what people were telling me, what some of my friends had mentioned about being in some of the lower level math classes, that was how they felt it was going. And so it's always very odd to kind of look from the outsider point of view on those lower level math classes, because you know that it's not perfect, but there's not a great solution. And the public education system, especially in math, is just somewhat inherently flawed to many degrees. And so it becomes very difficult very quickly to try to sort out how do we get you to where you need to be, which is part of the reason why I really like the idea of teaching high school, because I don't know if I want to do high school or college. And so kind of being that step where it's eventually okay, we are where we are right now, let's get you to some level of proficiency before you actually make it to college. So I have always really loved math. I'd narrow it down to a branch, but honestly, I like a lot of them. Stats is probably my least favorite because she's mostly writing. I'm in geometry right now, and I was initially a little frustrated because I was like, I feel like this is just high school. Give me real geometry. But I've done, abstract algebra and proof writing, and it clicks in my mind, and it's very satisfying that it's like there is an answer, and this is how we know it's the answer. And so you hit points, Math 315, algebraic structures. One of the first proofs that you have to write is, why is it when you add two even numbers, you get an even number? And I would look at my non-math friends, and they'd be like, well, that's obvious. Like, I've known that since kindergarten. Like, why is that your 300 level math course? And the proof for it is a little more complex because you have to show, an even number is defined by this. And so if you add two even numbers, it's going to be this plus this, and then you can factor out the two, and so it's still an even number because integers are closed under addition. Just rules and things that are like normally jargon, but when you really look at it, it's like, this is why. It is a rule, and we know for certain. It is very certain. Even now, like, I'm in physics, and half the problems are like, okay, there's this cow, but it's a sphere because we don't want to deal with shapes. And oh yeah, ignore drag, ignore air resistance, ignore all these things that make the problem harder. And I get it, I do, because I don't want to deal with non-spherical cows and air resistance. But math has always felt very tangible and very real in the sense that it is the answer. It's undeniably the answer. We can prove it. And there are so many ways to get there usually. You get one problem per se. And I remember sitting in calculus, and it was like, okay, how do we find the integral for this? And it's giving us a graph, and I say, this is going to sound really silly. You can just count the squares, and that's in fact the area under the curve. You can just count the squares, guys. And they all went, is there a reason that won't work? And the teacher goes, no, that works. We just want you to also be able to take the integral. And so we did, learn how to take the integrals, but there are more than one ways to get one answer, usually. And so finding out how to get there is really nice. And then when you are there, what can you do with it? And how can you go those other paths to kind of backtrack and see all the little connections? So I've always really, really, really liked math. I think so much of my love of math actually started because I did a lot of math from a very early age. I had a silly math game that was teaching me algebra whenever I was like 8. And then whenever I got to like 8th grade and we were doing algebra, I went, oh my God, this is Dragon Box algebra. This is literally the algebra. This is the game on the family iPad. Oh my God, guys, this is so fun. You can just, this is great. And so I found, like, after watching that and then doing a practicum at a high school, there was one day I was watching a like Algebra 1 class full of freshmen, and some of them were just not getting how you move variables, which happens. And I was like, man, if I gave these kids an iPad and that silly little game I was playing whenever I was 8, they'd kill it. It'd be great. And so really viewing math as like something very solvable, that's kind of what built it from a very early age. These days, I think in terms of like studying and learning, it is finding really and truly why things work is what makes it click. If you know that you can use a formula and it will work, that's great, that's fine and dandy. But that doesn't mean that you understand it. If you can derive the formula from the problem and you can say, okay, this is the answer because it has to be this way. It's not the answer because it is, it's the answer because it has to be. And I found this formula that, works, but it has to be this way. And that is always very satisfying. And so understanding like how things work and how they get there, not just I've been handed this formula and I don't know what it means, but I know that I can plug things in. You can only get so far like that, but if you understand why or what's applied to or where it goes, even like silly conclusions that you would never ever think, like there's no way that happens, and then you're like, oh my god, that's true literally all the time. I was chatting with a friend one day about topology, of all things. Have I taken a topology course? No, but I watched a lot of topology YouTube videos in middle school, as one does. And I was saying how when you're looking at the Earth, there are always going to be at least 2 points directly opposite from each other that have the same temperature and barometric pressure. Always, at least 2. It's impossible for there not to be. And that sounds crazy, and that sounds made up. And you hear that and you go, that's not true. Like, why would that be true? You just have a different temperature and pressure. Like, that's not true. And then you get into the topology and how you map the points to one another, and you find that like they have to intersect. There's no other option but for it to be true. And going from like an objectively true statement, but you don't know why, to a concrete explanation of it is really satisfying. And to me, that's the heart of mathematics, of like, why is it like this? It has been really interesting in the sense that I started pretty ahead because, of how high school was. And I am a double major in mathematics and secondary math education, which I always say, but usually someone will drop one or the other. And so in my like pure math courses, you definitely look around and you get the sense that's like, oh, where are women? Are we? I don't think I've ever had a math professor here who has identified as a woman for any of my higher level courses. And so there's definitely an element of like, I am here. And I think there's always a sense of imposter syndrome being a woman in STEM, of like, they know what they're doing, I don't know what I'm doing. And then you really start talking to some of those jokers and you're like, oh, I overestimated you. And so I've done really well in my classes, and I definitely take a lot of pride, and I'm very happy to be in my classes. And I have found very quickly that those other few women, you find them and you hold on tight and you say, okay, when are you taking this class? Because I don't want to be the only person in there. And so I've met some really, really lovely people just because we've bonded of, there's like 4 girls in here, we're running out of options. And so that's been really good. And that's for like more of the pure math side. You hit the math education side and is mostly women. And it's really nice to be in a class of mostly women. And the way that the math education courses are structured is a little different in the sense that it's not necessarily about pedagogy, and it's not necessarily like super higher content level. Like, you're not learning Calc 3, you're not learning it's geometry or statistics. But it's definitely very comforting, and there is a sense of, especially because it's focusing on education, there's a sense of like collaboration and working together, and how do we explain this? And so it's very nice that those classes are not necessarily dominated by men.